day to you out there. In this class, we want to be looking at another definition of oxidation and reduction. But we are going to focus our attention in this class to the definition of oxidation and reduction that define oxidation as loss of electron and reduction as gain of electron. Don't forget that the two definitions of oxidation and reduction, they used to be opposite to one another, yet they complement one another. Now, I want you to take note of this. When an element loses an electron, its oxidation number will increase. Take note of that. That is very, very important to take note of. And when an element gains an electron, its oxidation number will be reduced. You should remember, when you have an element or when a metal is inside a solution, when you put a metal into the solution, that is inside the aqueous solution, inside the water, for instance, you'll discover that there will be transfer of electron, whereby the metal atom will release an electron. When it releases an electron, it becomes positively charged. Yet, the non-metal will accept an electron. They used to be the electron acceptor. And when they accept an electron, they will become negatively charged. Another thing to note is this, because it's going to be useful in this class. Another thing to note is that when you have any atom or any element in its neutral state, or that particular element is just standing up. For instance, when you have the form of the 1 mole of hydrogen is this, 1 mole of oxygen is this. In this state of each of them, their oxidation number is going to be 0. Not only the two of them, any forms of element that occur when we are trying to do if there is no charge on them, their oxidation number will be equal to 0. So I'm going to show you a few examples now, which is going to give us an insight properly into what I am talking about. I hope you are going to bear with me. So let's go. Now, I have this forms of the first reaction here, where we have the zinc reacting with copper ion. This is called copper ion. This is zinc atom. Zinc atom reacting with copper ion. When it comes here, this one becomes zinc ion plus a copper atom. This is copper ion here. This is copper atom here. Zinc here. This is zinc ion here. Now, this is obvious from what I have given you so far, that this one here, this particular element here, the oxidation number of this element here is 0. This zinc, oxidation number of zinc here is 0. The oxidation number of this copper here is plus 2. You can see there, it is what we have on it that is written there. That's the ions that is on it. The oxidation number of this zinc here is plus 2, while the oxidation number of this copper here too is 0. Now, what you discover here is that what we have here, we have only copper here, but the oxidation number is written on it, likewise zinc here. So, with regard to the oxidation number of these two of them, we take it into consideration like that. But those ones that do not have charge on them, that are just a neutral atom, the oxidation number will be equal to 0. Somebody might be asking me that, what if we have sodium chloride? When you have sodium chloride, the oxidation number of sodium here is plus 1, while that of chlorine is minus 1. Because for any compound to be formed at all, there must be addition of oxidation number, where the addition of all those oxidation number must be equal to 0. That is why you have it here like that. So any forms, if sodium is only occurring alone, for just Na added to another thing, the oxidation number of this sodium here will be 0. What if it is like this? The oxidation number of this sodium here, we are going to call it 1. I hope you are very clear with this explanation I've given you. Now, let's look at what compound or what element is undergo oxidation, the process here, and which one undergo a reduction process here. In this case here, you have zinc here. The oxidation number here is 0. The oxidation number here is +2. Another thing I need you to take note is that don't mistaken this for what we call loss of electron. This is oxidation number. Now, you can see that there's increase in the oxidation number from 0 to +2. According to what I have given you before, that when an atom or when a compound lost an electron, oxidation is what? Loss of electron. It will lead to what? It will lead to increase in oxidation number. So we have called this one oxidation process. So don't take it as, oh, this is 2 before, this is 0, and it has lost electron. No, that is not the case. So you have to consider it from the fact that when an atom lost an electron, its oxidation number will increase at the product side. So that's what we have here. This one, this one, it gains an electron, and its oxidation number become reduced to 0. So look at it, +2 to 0, it gains an electron. That's the meaning of that. And its oxidation number will be reduced. You can see from +2 to 0. That is reduction. So that is what? Reduction. Reduction. All these are very important to take note of and be very, very careful about. Because if one is not careful, you can just say, oh, this one is 0 here, this one is plus. This is reduction. This is reduction now. There will be what? Oxidation is the process whereby there will be loss of electron, which is going to lead to what? Increase in oxidation number. What we call it is loss of electron. We do not call it gain of electron. Now, another example I'm going to show to you here. We have copper 2 oxide. Yes, this is copper 2 oxide reacting with ammonia. This is the reactant side. So what will we have at the product? We are going to have copper reacting with this. We are going to have copper standing alone plus hydronitrogen plus water. That is what we are going to have at the product side there. Now, we are going to look at the oxidation number of what we have at the reactant here, and also use it to consider what we have at the product side. Now, from here, oxidation number of copper here is +2. Oxidation number of oxygen here is -2. That is why they can form a compound, because when they are able to combine together, they'll be able to form a compound. Oxidation number of nitrogen here is -3. That is why it needs to be reacted with what? 3 hydrogen. So oxidation number of hydrogen here is -1. Oxidation number of copper here is 0. Why that of nitrogen here is also 0. You can see that this is in their neutral atom form. And the oxidation number of hydrogen here is +1, +2. That is that of the +1, sorry. And that of the oxygen here is -2. You know, when you have it to be +1 times 2, that's 2 of it. Now, you will discover that this oxidation number of copper here, it has reduced. You can see from +2 to 0. What happened to that? That is, it has reduced. That's what? That is reduction. That is, the loss of electron leads to what? Decrease in oxidation number. We call it reduction. What else? If you look at it very well, oxidation number of oxygen is -2 here, and the product side is also -2. Nothing to do with oxygen there. We are not considering oxygen. Oxidation number of nitrogen here is -3. Here is 0. What happened to it from -3 to 0? It has increased. Because which is greater, 0 or -3? It is 0 that is greater than -3. So it has increased. So from here to here, we call this oxidation. Because oxidation is referred to as loss of electron, which is what? Which is related to increase increase in oxidation number. So that is how you're able to get what we refer to as oxidation and reduction. It is kind of a reaction of loss of electron, and reduction being referred to as gain of electron. Take note of that. This is very, very important. I hope you have been able to enjoy this class. Now, I want you to take note of this when you are trying to deal with oxidation and reduction. This loss and gain of electron is very, very important. It's one of the most important method of simplifying oxidation and reduction. For instance, you just see a question that asks you to show the reaction, just to show you which compound is oxidized and which one is reduced, and you are confused about other definition. All what you need to do is just provide the oxidation number on them, look at them very well, then you'll be able to know which one is oxidation, which one is reduction, where it takes place there. I hope you have been able to enjoy this class. I hope you are going to stay tuned to our channel, invite others, so that you'll be able to enjoy all of the goodies together. Thank you for taking part, and God bless. See you some other time.